Thank you very much. Thank you very much for coming. I'm giving this talk on PyInstaller. PyInstaller is an open source tool that I maintain or co-maintain, actually. There are a few maintainers right now. Just a brief introduction of myself. I have 9 years Python experience, so I'm a medium-time Python user, maintainer of PyInstaller. I'm organizer in PyCon, the PyCon Italy conference and EuroPython this year and next year. I'm the CTO of Devler, which is one of our sponsors. And these are my Twitter and blog references. In case you want to follow me, I can offer a free beer, the first to follow me right now on Twitter. Thank you. Okay, so in this talk we set a goal, okay, that we try to achieve. And this goal is how to ship applications written in Python without any dependency, external dependency on Windows, Mac, and Linux. So I'm thinking of desktop applications here. So mainly desktop applications, maybe multi-platform applications that you want to ship to your users, end users, without dependencies, so without having to install separate third-party libraries or Python runtime, stuff like that, okay? So you want to distribute everything to your users in just one big package. And how can we get to it? Because usually when you write Python in source code, and the solution for C++ is to compile and then ship the executable. But alas, this doesn't work for Python because it's not possible to compile Python, as you know, unless the PyPy team is in this room. But if the PyPy team is not here, it's not possible to compile Python. And so what we can do actually with Python is just to package everything together. So we just grab all the dependency, try to put them all together in one big pack somehow, and then get all this stuff together to the user in an easy, friendly way, okay? So this is what we can do to achieve our goal. We cannot compile, we just need to get everything, including the Python interpreter and the third-party dependencies, put all together and ship it. And the solution I will propose in this talk is to use PyInstaller. This is the website. This is an open source tool. It's a GPL tool. It's free as in beer, as in freedom. And it doesn't impose any restriction on the software that you package. So even if the tool is GPL, I will not enter details of licenses, but even if the tool is GPL, basically you can use it to package software distributed under any license. So even proprietary code, commercial licenses, everything is fine. There is actually, the slide is a little cut, but I guess it still makes sense. So basically this is an overview of the distribution process. We start from the left. This is the blue rectangles are the source code or the input files, let me say. We have Python files, which is probably your application. We have DLL or SO libraries, shared libraries, which are part of our application. So for instance, if you're using, I don't know, PyQt, just to make an example, PyQt contains Qt, which is written in C++, so you have the Qt DLL on Windows or Qt SO library. And then, of course, you also have data files, because probably your application, non-trivial applications, have external data files, okay? So you have all these things together that work together in your sandbox, and you need to put them together. And what PyInstaller does for you is create a binary. A binary means a Windows executable on Windows, on which works with data, still with data, or a binary under Linux, so a native binary under Linux, or, for instance, an app under Mac, so a bundle, for instance, under Mac, and it stops right here. And when you get here, you probably have one executable and then some data files, and you still need to pack them and give to the users. There is another step, which I call the distribution step here, when there are various tools to do that, to end up with the final installer or package, okay? So, for instance, on Windows, you have all those wizards to install through. So there are open source applications like InnoSetup or NSIS, to create the wizards. On Linux, most users like to use package manager like Debian or RPM package manager. On Mac, you usually use a disk image, DMG file. So this second step is not part of PyInstaller. PyInstaller ends right here. Okay, so just create the binary. You still have binary data files and maybe other stuff. You need still to build a package, final package for your user through various tools. Okay, this is just to have an idea of the scope. Okay, this is a crash tutorial. You don't need to read this one. This is why little script. This is a small example of Matplotlib, which is a nice third-party library for doing graphs, computation, stuff like that. It's really nice because with a few lines of code, you get beautiful graphs on screen and stuff. But the idea is that this example shows the power of Python. You just import anti-gravity and fly, stuff like that. But behind this code, there are tons of dependencies. So Matplotlib is a good example of a large library with tons of dependencies. It has several backends for UI, several backends for various stuff, use NumPy and lots of stuff. And so even if the code is short and readable, works very well in Sandbox, it's usually a mess to get this into a binary that the final end user can use. This example using NumPy, PyQt for backend, for instance. So how do we use PyInstaller to use this? We first download the latest PyInstaller version from website, which is 1.5 at this point. You just unpack it to a writable directory. It's just a zip file or tar archive, whatever. There is no installation. Okay, just uncompress it, which means that, for instance, you can uncompress it in your Sandbox and commit it together with your program, because maybe you want to version and freeze it with versions of your application to integrate it with your build deploy process. Can be an idea. You can have a shared external PyInstaller or even one PyInstaller committed with your application. Up to you. Just unpack to a writable directory. I will call it PyInst. Then you just need to configure PyInstaller once. Just find a few dependencies in the system. And okay, this is the first real step, which is to create a PyInstaller project. Okay, PyInstaller project is a project file which contains description on how PyInstaller needs to behave with your application. Okay, so for this example, we just keep all the defaults in place. We just pass to make SPEC, which is the program to create a project. A project in PyInstaller's lingo is called SPEC file. So you use make SPEC and you pass it to your main application entry point. So the script that you run when you want to start your application, npl.py in this example, it writes an npl.spec for you, the project file, and then you run and suggest the next step, which is to run build.py against your spec file, okay, to create the application. This will spew lots of debuggy outputs, not very pretty, but it will create the executable for you. This subdirectory, project name subdirectory, so dist npl in this case, and you got your npl binary. You run it, bang, and you got the program. This is an example on Linux and PyQt of the source code I was showing before. Nice graphs, colors, and stuff. The same thing run on Windows installation is this one. It uses, on Windows, Matplotlib by default use TK. And this is the output. And it works on both of them. If you try this tutorial, it should work out of the box. Don't try it now, but when I'm not here, in case it doesn't work. No, sorry. I'm joking. It really works. I'm pretty sure about this. And to do this, PyInstaller has to do a lot of magic for you, finding lots of dependency. Matplotlib has data files, which needs to load at runtime. It needs to find them in your system where they are installed. So PyInstaller needs to tell Matplotlib, hey, those data files, I copied them here with you. So lots of magic going on to get to this point. And what's within this dist npl directory? We just run the npl binary, but what if I show you a listing of this directory? It's here. This is the listing of the directory. Actually, it's the listing for a Hello World application, so one-liner, okay? Print Hello World, one-liner. Here, Hello World is the main executable, so it's 600 kilobytes. It's the main executable, and then you have all these nice files. One is very easy to understand. It's the libpython directory. This is a Linux example, of course. It's the libpython directory 2.6, which is being used in this example. Okay? And then you have parts of the standard library. Okay? What we see here is the shared object at sea level of the standard libraries that PyInstaller thinks they are necessary for Hello World, which is kind of stupid, of course, because I don't think print Hello World requires the Japanese codec. Okay?
Only if you're Japan.
Only if you're Japan, yeah, and you write Hello World in Japanese. But the point here is that PyInstaller has no way to know that you are not going to use the Japanese codec, because how can it be sure about it? What should it do? It should parse all your input file and find all the encode calls with static analysis. And what if you pass to encode call a string? So you're encoding not just JEP and you see it, but you just encode and you pass a variable to it. And what if your variable are reading from a data file? So it cannot know that you are not using the Japanese. That's part of Python, the fact that you can decode from Japan. And there is no way PyInstaller can statically know this. What you can do is to tell him that you don't need Japanese, okay? And I'll show you how to do it, but it cannot do automatically. So what PyInstaller does is that, by default, it tries to be conservative, okay? It tries to make it work because you want to do this good experience of just running it, wow, it works. Yeah, maybe it just brings a few stuff you don't need, but it works. It's being conservative on this, okay? So these are all dependencies which are part of standard library, bzip2. We can also discuss of why heapq is a dependency required, but anyway, this is the way it is. And we now look into Hello World binary. This is the Hello World binary, which is basically made of two different parts. So I'm trying to show you how that binary works, because I said before it cannot be a compilation, right? We cannot compile Python. So how this hello binary works? Well, easy. There is the libpython in the directory. So the hello world binary is just made of a bootloader, which is a standard component of PyInstaller that we develop and just ship with PyInstaller. So it's a binary, part of PyInstaller, bootloader. And at the end of the bootloader file, we append an archive, okay? An archive or archive. We call it PYZ, and this package here, green, is a big package which contains everything that you didn't see in the directory. And what's this everything that you didn't see in the directory? Well, there is your code, so maybe the hello world.py or .pysc, better. But if you have a larger application, obviously this will be much more code. It contains the standard library, and this time it means the PyYC files of the standard library. We were seeing the codecs before, which are binaries, but there are also the PyYC parts of the standard libraries, which are needed, or PyInstaller thinks they are needed. And also PyYC file from third-party libraries. So basically, this archive is all Python, pure Python code, okay? Bytecodes packed together with zlib to be a bit more smaller, and they are never extracted to disk, okay? So all these files together are packed, appended to the bootloader, and the file is renamed with the name you want to give to application, which is Hello World in this example, and the bootloader will just run, load the libpython library, and feed it with this Python source code, okay? And it can feed the Python code to libpython without extracting the code to disk, thanks to the Python import hook mechanism. The Python import hook mechanism is a way to plug into the import statements of Python. I will show this. So when you run an import statement, like import anti-gravity, what CPython does in a word is basically goes through the syspath list, okay, which is the list of directories on disk where libraries, Python libraries are available. So there is the standard user libpython site packages directory, and there can be more directory in that list. And when it goes through the list, it can find a few things. One thing is directories, as I said before, but it can also find zip files, for instance, since Python 2.3. Python can import zip files transparently. So if it finds a directory, it will execute some code. So it's like a plugin. Is it a directory? Yes, execute this code. This code is the file import, which means find the file in the directory, import antigravity. So antigravity.py must be available in one of those directories and import it. If it's a zip file, you will just look within the zip file and extract the anti-gravity code, okay? So as you can see, it's pretty close to what PyInstaller does. The only difference is that we don't have a plain zip file available. So, but we have this PyWASI archive, which is part of the executable itself, right? And so we just hook into this mechanism. So if you print sys path from within a binary packaged with PyInstaller, you will find one additional entry, one entry that you would, you don't know what it is, but it's a reference to this PyWASI file. So basically, the syspath references the binary itself in a way that, with the import hook mechanism, let the bootloader code load file from the PyWASI archive and feed them into Python, okay? I mean, it's not different from what happens with the zip file, actually. I know Py2X, for instance, is using directly zip imports. We don't use them for a mix of historical reasons and other stuff, but it's mostly the same. So under Windows, for instance, you have all these files, a little less than Linux, the example we were seeing before, but just because the Japanese codec are just part of the Python library under Windows, so it's just cheating, but they are the same dependencies. Can we do better than this? Because at the beginning, I was promising that I will be giving you one binary and your data files. But here, I'm giving you one binary and like 10 external libraries. So can we do better than this? Yes, we can. But we need to tell PyInstaller how? Through the project file. I told you that we were going to use the default project file before. So now we regenerate from scratch the project file. We just change the make spec invocation by giving it one additional option, which is --1 file, which, as the name implies, tells PyInstaller to try to do a single file. Okay? You rerun build on the new project file, and you get one output file, which is hello world. 2.1 megabytes, it's one compressed package with no external file dependencies, everything put together, ready to download and run. So what did PyInstaller do? It just put all those DLL together within the hello world binary attached to it. So, same diagram of before, mostly. The only difference is that in addition to the PyWASI archive, we also have these red boxes, shared libraries, and data files. So basically, or in this example, I didn't put data files, but we can put them as well. I just put shared libraries within the single binary. But in this case, we don't have a way to load operating system level shared libraries without extracting them to disk. Okay, so with Python, we have the import hook mechanism, and PyWASI file, we can load them without extracting them to disk. For DLL and SO shared libraries, we cannot do that. So we need to extract them to disk, okay, at the beginning. So what PyInstaller does is that when the bootloader starts, it looks within this archive and say, okay, there are some shared libraries here. I need to extract them to a temporary directory, and then it reruns itself and tells the operating system that there are some additional shared libraries into the temporary directory that it can look and find, okay, to find the dependency. This is, of course, a slight overhead compared to the one directory mode, because in the one directory mode, you just start, and the operating system, when it needs, it finds the DLL on disk and just load them. While here, we need first to wait for the bootloader to extract them to a temporary directory, okay, and then rerun the application. It's a small overhead, depends on how big are your dependencies. If there are, I don't know, 50 megabytes of data, can take a while, especially on Windows, where I/O we know that it's not really good. And obviously, the bootloader will try to remove the temporary directory at the end of the program, okay? Okay, if you want to have a look at this file, you want to see, okay, I got this binary here, but what's inside this binary? What did PyInstaller put within this binary? You can use this tool, which is Archive Viewer. Archive Viewer, you run it against your PyInstaller binary, Hello World, for instance, and it's an interactive tool. There is a small prompt here, and it will dump the contents of the archive. So here, Hello World, the contents, you can see the same files, codecs, Japanese, stuff that were on the disk before, okay? Now they are within the PyInstaller binary, and they will be extracted to the temporary directory when the binary is run. LibPython and everything. And here, you can find the PyYZ archive I was telling you before. If you open it with the O command of the Archive Viewer, you can open it, dump its contents. You will find all the PyYZ files that it contains. So you can see this is part of the standard library, all dependencies that PyInstaller thinks your application needs. So calendar, bisect, BDB, base64, and these are all Python standard library, Python source code files, okay? Just compare it to Python, PyYZ files, but they are standard Python files. So this one, first level, is binary SO files. The PyYZ archive, second level, is the PyYZ files. These are never extracted to disk, as I was saying before. Okay, so we had this little overview of PyInstaller, how to use it, a crash tutorial. So some feature reel for PyInstaller. So it's free, as in beer and freedom. Is a multi-platform tool. Is multi-version, so it nominally works from Python 2.0. Okay, no Python 3 supported at the time. We are still investigating it at the time. There is no code being developed, so I won't lie you. There is still no Python 3 support in progress at this point. We are trying to understand how to get there. We run test suites before releases on Python 2.2, and it works. Python 2.0 should work. We don't use specific Python things, but might be a little broken. Yeah, open source code. And also there is this flexible packaging mode. You just get a quick idea of what I mean by flexible packaging code when you saw that you can have one dir or one file distribution mode. It can be much more than this, and I will show this. Advanced built-in support for specific third-party libraries, which means that, for instance, PyInstaller knows what to do for matplotlib specifically, and what to do for PyGTK specifically, and what to do for many other support libraries, third-party libraries specifically. We maintain this code for you, so that when you use matplotlib, you don't have to care how matplotlib works internally to be able to package it. And transparent compression through zlib and UPX. UPX is a binary compressor available on most platforms. On Windows, PyInstaller creates executables that run on Windows 2000 plus with newer version or newer vanilla with no separate CRT or runtime installations. So this, in my opinion, has been a great achievement because I didn't do it. I will not be able to do it, so for me it's a great achievement. I'm really grateful to the maintainer who contributed it. So basically, if you know that on newer Python version on Windows requires separate installation of Visual Studio CRT runtimes 2008 on your system before running anything. But with PyInstaller, we managed not to have this dependency. So for Py2X, for instance, it works on Python 2.6, but then you need to ship both your program and the separate CRT for your end user to install. Of course, you can automate the installation, but you need to ship both, while PyInstaller's executable are self-contained. And works for both WindowEd, the console mode application, uses UPX to compress transparently everything, can embed icons, modify PA version info. Co-designing is supported, which means that if you care about the Windows co-designing program, you can co-design a PyInstaller executable. It will actually check integrity and signing of the whole package, big red, blue box. So it means that you're actually signing all the code, also third-party libraries, everything together. And there is also support for COM service, which is deprecated for lack of maintainership. On Linux, of course, the main problem on Linux is that there is no fixed APIs across Linux distributions. I mean, there is the LSB, but there is not really fixed APIs that we can rely on, because you probably, when you use your Python program, you're probably using a lot of libraries which are not LSB compatible, so we cannot fix this for you. If you're using only LSB stuff, it will work. But if you're not using only LSB stuff, we cannot fix this for you. So what we try to do is just trying, the point is that there is no clear line on Linux on what is a system library and what is like an application library. Because of libgdk, just an example, on Windows, there's no problem. You know that you want to bring it with your application and ship it. But on Linux, is it better to use the system one on the end-user system or use the one you tested it with? Depends. There is no good answer to this, unfortunately. So what we do, we try to be distribution independent by default, which means we try to pack as much as possible without crossing that line where things will crash. So for instance, if you just get libgl, it will crash because your libgl relies on your drivers, so you can ship this to other users. There is no compression on shared libraries on Linux, but this is not really important. On Mac OS X, we can create bundles for Windows web application. We are forward compatible for version, but this is standard Mac OS X guarantee. I mean, we are not adding anything to how binaries work on Mac OS X. You can embed icons. We don't support universal binaries for all the PPC users among you. And UPX is not supported as well. So I'm focusing on differences mainly, but basically most of PyInstaller features are available on all platforms. Back to the flexibility, I was saying that you have the SPEC file, which is a PyInstaller project. And the SPEC file is usually generated by makespec.py. I say usually because the SPEC file is just a standard Python file. A standard Python file which is actually being executed by the build process, and it just describes one by one the steps to do to build your application. So it just tells PyInstaller, okay, do this, then do this, then do this, then pack these files, then look for this dependency, then zip this stuff, append here, and bam, and this is the final product. So this is the main point of the flexibility. Since it's a Python file, you can hand edit and you can decide what PyInstaller must do for you. So you can use PyInstaller sort of like it's a library for you. It gives you some nice tools to tracking dependency and stuff, and you can just decide what to do with it. So makespec is just a wizard. It generates template spec files for you, standard templates file. So you can tell him, okay, I want a one file or one dir mode, I want a window web executable, I need some debug, I want to ship an icon. So it's just a wizard for your first day or year with PyInstaller. But if you want to achieve maximum flexibility, you can just open your spec file and hand edit it. It's not pretty, but it works. This is a spec file. You can see there are three main steps. The first one is analysis, then there is a PYC step, and the next step. The analysis step is the step which basically tracks all the dependency. So you are passing to it hello world.py, which is your entry point, plus two files which are internal detail implementation of PyInstaller, which shouldn't be here, and we will eventually fix this. And then you pass a pathx variable, which is sort of your Python path. Python path is part of the environment. Maybe you want to hardcode some internal Python path directory for PyInstaller to use. When you run this command within your spec file. So basically, this spec file is executed by build. So you can change it, and when the build gets to execute the analysis, what happens is that it basically starts from hello world.py and recursively analyzes byte code, PyYC files, parse them and analyze them, and finds all the dependencies, okay? And it finds all kinds of dependencies, both at the Python level, at the OS level, and mixed level. Python level dependencies are basically your import statements. So import foo means your application depends on foo, really easy. You can have conditional imports. So if something, import anti-gravity. In this case, PyInstaller is conservative. Again, so it cannot know if the if condition will be always executed, sometimes executed, or never executed. Okay? So what it does is just assumes that maybe it will get executed and will bring the dependency in. Another problem with the Python level dependencies is that there can be hidden imports. For instance, if you use the under import statement and you dynamically generate a name of a library, like in this example before, PyInstaller has no way to understand what you are going to import. It cannot statically analyze this and find out where are your plugins, of course. So in this case, you will need to tell him there are some dependency by adding them to the analysis step before. You just add those files there, and you will track further dependency. Dependency, so these are dependency at the Python level, so what you can do from Python to depend on an atom Python module. At the OS level, you have dependencies between DLLs or between shared objects, and PyInstaller can follow dependencies on Windows. Dependencies are on the PE import section or through manifest parsing. On Linux, we just invoke the LDD tool and trust its output, and the same on Mac with the OTool tool. Nice. And there can be hidden imports at the OS level as well, because, for instance, on Windows, you can use load library, or on Unix, you can use dlopen to dynamically load a runtime a library, and PyInstaller has no way to know that your SO file will call at some point dlopen. There is no way to do it just by looking at the SO file. So this is an hidden dependency that you need to manually tell PyInstaller about by modifying the spec file. You can try to list all the dependencies that PyInstaller sees at the OS level by running bin-depend, which is a tool. You just pass it, for instance, a PyWD file, DLL file, whatever binary file, and we'll just dump all the dependencies that PyInstaller knows about. So you can check if there's something missing, for instance. And then we have those mixed Python OS dependencies, which is basically C-types. Because in C-types, you basically create a OS-level dependency from Python. Because with C-types, your Python application depends on a DLL file directly or a SO file directly. So, for instance, I don't know how many of you have ever used C-types, but for instance, if you do cdll library.so, C-types just loads that library and tries to make all the function in it available at the Python level for you. So your application will need this file to work. And the nice thing is that PyInstaller can find these statements in your source code and understand there is a dependency and follow it. So if you're using C-types like this, which means that, for instance, you are passing an immediate string here with the name of the library, PyInstaller will know that you are using library.so and will bring it into your package. Okay? So we have an explicit support for C-types. It works only if you're using immediate strings, of course. Otherwise, it cannot know what library are you using. If you say cdll library under name, it cannot know what library you are going to use. But since most of the times with C-types you explicitly name the library you use, it works pretty well. As I said, there can be many hidden imports that you need to tell PyInstaller, but what we try to do is to leave you with the only task of tell PyInstaller about your own hidden imports and let PyInstaller know about third-party libraries' hidden imports. So for instance, this is the, I don't know if it's contrasted enough. Can you see the slide? Not really. Basically, it doesn't really matter. It's just the internal, it's a file part of PyInstaller, and it's the hidden import hook for PyQt4. Basically, through this file, PyInstaller knows that PyQt needs, for instance, all these plugins, because Qt has a plugin system. So, for instance, image formats like JPEG, PNG are all plugins of Qt, external DLL files. Through this file, I'm telling PyInstaller, okay, if you are using PyQt4, the application will need all these plugins. Again, I cannot know which plugin you are going to use, so I will bring everything, every one of them with your application. So I'm just telling PyInstaller, okay, you need all these plugins. So the idea of these files is that we maintain them. You don't need to know. So you just use PyQt4 as a normal library. You load the JPEG files, and it works in your sandbox. You run PyInstaller, and it still works. But under the hood, PyInstaller is looking at this file, is deciding to bring all plugins, and it's also telling at runtime to PyQt where to find the plugins, because otherwise PyQt couldn't realize by itself where the plugins are. So it's doing a lot of work behind the hood. As I said before, you can hand edit your spec files for instance, to manually add the includes or excludes for compilation. For packaging, you can add data files. You can use custom packaging mode. For instance, we are working, it's already available by hand editing spec files, but we plan to put this open source mode into the Make Spec wizard for everyone to be readable available. The open source mode is a nice packaging mode where everything is packed together in one binary, but your source code, which means that you're shipping an open source application. Think of Mercurial, for instance, which is a Python application. You're shipping everything into one big Mercurial binary, but Mercurial source code, which is there in the directory. So basically, if you want just to apply a patch to Mercurial, it's there on the disk. Just modify the files. Everything else that Mercurial depends on, third-party stuff that you don't need to patch, they are all together in one big file, but the source code of the open source application is on disk for end user to modify, which is nice because it means that you can modify Mercurial to apply a quick hack even if you don't have a Mercurial sandbox directly from the Mercurial distribution package, which is, I think it's really nice. One question that I get often asked by customers we work with is they come to me and ask about, is PyInstaller a way to avoid the reverse engineering my application written in Python? Is a way to kind of hide my source code better than I can do without PyInstaller? The question is not really, because as we said before, we're just packing everything together with an open source tool. So just the way we pack it, you can depack it. So we are not really doing anything more than that. We do not never ship, a PyInstaller package never contains raw source code. It always contains bytecodes, okay? So this is just, it's equivalent to sending the bytecodes to your attacker for having him reverse engineer your code, okay? So there is some basic cryptographic support, but nothing really important. The only thing I want to mention is that a solution that some like to deploy, for instance, Dropbox is using this solution, is to do bytecode scrambling, which means that you basically recompile your CPython interpreter. You just get that one header file when all the bytecodes are defined, like define load up 8, and you just shuffle the numbers, which means that your bytecode files will have the standard Python statements, but all the since they are all shuffled, a standard Python interpreter cannot run them, okay? And a standard Python bytecode decompiler cannot decompile them. But since you are shipping your own custom Python version with scrambled up code together with your application, it will be able to run. Okay, so this is probably the most effective way to let me say, delay reverse engineer of our application. Okay. Yeah, obfuscate. Yeah, I was looking for that word, obfuscate. Actually, if you want to do it as good as Dropbox does, it's not sufficient to just scramble that one file. You just want to, for instance, disable the internal DIS module of the standard library, which is the disassembler, because otherwise you are shipping a disassembler compiled with your own scrambled bytecode with your application, which is not a good way to obfuscate your code scrambling. So you just need to, there are a few ties to follow, but it's actually quite effective. So in the future, for PyInstaller, we are planning to have, actually it's already committed on trunk, a one-stop binary, one-stop script to do everything in one big step. You just unpack PyInstaller and run PyInstaller app.py, and you get the binary without everything else, which is something that we get used by many people who don't like to read the manual, so they just want, to run stuff. We, of course, are planning to improve third-party library support, to keep on maintaining. This is an ongoing effort because the library evolve over time, so we need to follow their evolution. Python free support is in discussion. We are trying to understand what means to add Python free support. And we are also investigating covering the this phase. We already have lots of code available for this, but it's not ready to be. There are licensing issues, but we probably could get to the point where over the course of 2011, we could ship a new version of PyInstaller which also covered the this phase, which means that basically have some basic support to automatically run setup for you on Windows or create a dev package for you, stuff like that we need to integrate somehow and see how it works out. Okay, I'm finished.
Is PyInstaller able to package Windows services into a single file?
No.
User.
Actually, I said no. Too fast. We will have to check because I guess I remember that someone managed to do that. So I will have to check if it's just a matter of changing a little few things or if there are more important things missing. I actually don't remember because I personally never worked with a Windows service, so I'm not sure what's missing. But actually, if you probably Google it, you can find some, in the mailing list archive, you could probably find some leads about it.
How does PyInstaller finds all these import things? With regular expression or some other technique?
No, bytecode parsing. PyInstaller always works at the bytecode level. So if you have a Py file without the bytecode, it will first compile it to you, to PyYC form, then it loads the bytecode, and then follow the dependency at the bytecode level. So basically, go through all the bytecodes in there and find the import bytecodes.
How does PyInstaller deal with LD library path, etc.?
With the LD library path. Basically, PyInstaller, when you run build.py, when you build on your system, it will follow the LD library path because it runs LDD under the hood from within the same process. It will follow your own LD library path and thus find all the libraries. Then all the libraries are packaged packaged together, so you don't need your LD library path anymore at runtime. Doesn't make sense to you? Yeah, that's another point. It was saying that at runtime you still need to find the library. That's true. It's not your system LD library path, but PyInstaller will set an LD library path for you so that the operating system finds the libraries in the directory where PyInstaller put them.
I would like to see the multi-platform support extended with the Sun OS and AIX. Could you please put that on your future plans list?
Should I answer with patches welcome? No. I think some Solaris support used to be on place a few versions ago, but we don't have a maintainer for those platforms, which means that it's hard for us to test and see if it works, it still works or not when we release newer versions. If you like these kind of things, you could at least try to contribute with bug reports, which is a way to get people started. So if you try PyInstaller on those platforms, there is in the manual you should find some guide on how to try on different platforms, so you can try, and then if you contribute bug reports, we can at least get an idea of how far we are from supporting newer Unix platforms.
Thank you.
Any other question?
Is the spec file is the same for all platforms?
Should be.
I see exe section in spec
it should
file.
be modulo bugs. should be the same. Actually, make spec is so stupid that manages to generate a spec file which is not multi-platform, which is incredibly stupid, and I don't know why we don't fix this. But it's really easy to make it multi-platform, and that's the idea.
Any more?
When I build a RPM or deb, can I ask PyInstaller to use the default Python installation in my Linux distribution or require to install dependencies?
So you want to use PyInstaller in a way that you don't ship your Python and Python standard library,
yes,
your binary, just only the dependencies.
Standard deb or
yeah. But you want to, for instance, if you use PyGTK, do you want PyGTK to be included in your deb or just track it as an external deb dependency?
Just track it as an external dependency.
Okay. There is no standard way to do this, but so what you are asking PyInstaller is to do a subset of what it does by default. So it's something that you can achieve by hand editing the spec file, because you just need to remove steps, you know. So you just need to remove steps from that and then create a deb file with the correct I'm missing dependencies. Now I was looking for how in the deb file the script is called, the one that lists the dependencies. I don't remember the name. Sorry? Okay, that name.
Okay, I think we still have room for one question. Okay, back there.
So for Linux, mostly, have you considered getting rid of temporary files for the SO libraries?
Do you have suggestions?
Yes, but they are too technical. Maybe an outline of one suggestion is you could relink your binary and your libraries to a statically linked one, like include libpython, libc, and things like that. This sounds complicated because you have to write a linker. As far as I know, there is no such linker which can take SO files and binaries and output a statically linked binary. Another option which would be easy to implement is to modify libdl so it can map an SO file not from the beginning of your binary but from the middle, and then don't compress the binary.
That's actually interesting. That's actually interesting. More files. Mod files. Yeah. User mount. Yeah, we need to think of it. Actually, the idea of relinking is actually nice. Relinking all together. There is this gold linker on Linux. Did you hear this gold linker?
Do you know Tickle star kits? These do load their dependencies, their DLLs from memory, so you could just copy the code. It's basically BSD. They do it on OS X, I think Linux and Windows, without temporary files.
Yeah, we want to. I don't know this. What's the name of the library?
It's a similar packaging system for Tickle called StarKits, which does basically mostly the same thing.
I found some solutions like this. The only thing that we want to make sure is that we are not exploiting some tricks in the operating systems, because we don't want to get to the point where everything works, but you're using a tricks on the wrong Windows version or something like that. We don't want to get to that point. But probably, eventually, we should probably investigate those solutions. There are nice ideas from you. Thank you, guys.
Okay, I think we are done. So thank you, Giovanni.
Thank you.